Hi, welcome to this video on differentiation for additional maths, focusing particularly on changing your algebra into what I call index form before you start your differentiation. Okay, so differentiation without fractions and without square roots and cube roots and things is reasonably straightforward, and actually it's really difficult if you try to do it and leave the fractions and roots inside. Okay, which is why at GCSE you were taught how to convert square root of x into x to the power of a half, cube root of x into x to the power of a third. Okay, 1 over x becomes x to the minus 1, and so on. Okay, that was to help at A level when you want to do differentiation and then the opposite of differentiation, which is integration. Okay, so if we have a look at some questions. So we're going to find dy by dx, so we're going to differentiate, find the gradient of this function, so y equals 1 over x squared. I mean, it's not horrible looking, but if we want to differentiate it, we can't leave it looking like that. Okay, so a little bit of indices revision then. I'll rule this off, look. So we've got a rule that says if you have 1 over a, then that's the same as a to the power of minus 1. Okay, a minus power means 1 over. If you had 1 over a cubed, that would be a to the power of minus 3. Okay, so still cubed, but 1 over that. Okay. I mean, while we're here, we may as well go over some of the other ones, which is that square root of x is x to the power of a half. Okay. The cube root of x would be x to the power of a third. So when you're differentiating and you're seeing these fractional powers, that's really what we're saying, is that there's some kind of rooting going on. You would have also seen at GCSE that if I want to do the cube root of x squared, okay, because it's cube root, the denominator is a 3, but because we're then squaring, you get a 2 on the top. Okay, so we're not just making up these horrible fractional powers for the sake of it. That's to do with doing all different types of rooting and then squaring. Okay, and you need to get it in index form before you can even think about differentiating. So for this one then, I've got 1 over x squared. So to take out the 1 over, to make it into just index form with no fraction, that would be x to the power of minus 2. Okay, now we can actually differentiate it. So dy by dx, and remember the rule is that the old power comes down and multiplies, so we'll get a minus 2 in front as a coefficient, and then you drop the power by 1. So if we were on minus 2 to begin with, that goes to minus 3. Okay, you could rewrite that as minus 2 over x cubed, but you wouldn't bother. Okay, just leave it in index form, it's neater anyway. Okay, number 2. Okay, this time we've got 4 over x cubed. So you'll know from GCSE that 1 over x cubed is the same as writing x to the power of minus 3, but how do you write 4 over x cubed? Well, the 4 is because the whole thing has been multiplied by 4. That's how you get 4 over x cubed. It's 4 lots of 1 over x cubed. And so all you do in your answer is you'd include a 4 in the front. Okay, 4 lots of 1 over x cubed, so 4x to the power of minus 3. So first of all, rewrite it in index form. Okay. And the 4, which was the numerator, just becomes a coefficient. And then we differentiate. So dy by dx. So let's bring the old power down and multiply. So minus 12 now. And drop the power by 1, x to the power minus 4. Okay. Now the next one's a little bit trickier because it's a bit of a jumble. So the first term is fine, that's already in index form. The second term is already fine as well. So that's what I was saying earlier, we've got x to the power of half, so that's just a nice way of saying the square root of x. If I wrote that out, it would look like that. Okay, we don't like that because it doesn't fit into our little neat rule of differentiating, of bringing powers down and things. So that's why we got rid of the square root sign and written it as x to the power of half. So that's good because that's already in index form for us. This has got no powers anyway. This is a problem. So this is the term we're going to have to rewrite. So y equals 4x cubed plus 2x to the power of half. I haven't done anything yet. Okay, and then we've got 4 over x squared. So remember, that's 4 lots of 1 over x squared. 1 over x squared becomes x to the power of minus 2, because the minus power means 1 over. So 4x to the power of minus 2. And then we've got our plus 7, which will disappear when we differentiate anyway, because it's x to the power of 0, and we'll just go. Okay, so dy by dx then. So the 3 comes down and multiplies. That gives us 12. Drop the power, x squared instead of x cubed. For the next term, the half comes down in front and multiplies. So that's half of 2, which is 1. Now you can put the 1 in, but you don't have to. So just x. We were on a half, a positive half, and we're taking away 1. So now we're on minus a half. Okay. Then we've got the term that we changed. So that minus 2 is going to come down in front and multiply. And what's going to happen is that it's not going to stay as plus 4. When you multiply, it's going to go to minus 8. So let's get rid of that. It's going to go to minus 8 x to the power of minus 3 when we drop the power by 1. And the plus 7 you can just forget about because it hasn't even got an x in it, so when you differentiate it, it goes. Okay, and then that's fine. Leave your answer like that in index form. There's no need to muck around trying to convert it back. Okay, one more example then. So if we go term by term, our first term is fine, 12x to the power of 5. We can differentiate that easily. Then we got this one, which isn't very nice. So that's 2 lots of 1 over x squared. So that's 2 lots of x to the power of minus 2. So if we write this out, look, so we've got 12x to the power of 5 plus 2x to the minus 2. Then we've got our next term, which is 3 lots of 1 over x to the power of 4. So that just becomes 3x to the power of minus 4. And that's being taken away at the minute. You have to be careful with our signs on this question. And there's our plus 5 on the end. Okay, so dy by dx this time. Okay, power comes down and multiplies. 12 times 5 is 60. And it goes to x to the power 4 from x to the power 5. Right, then the minus 2 comes down and multiplies. So that changes our sign to a minus, and we go to 4. We were on a minus 2 already, we dropped by 1, so now we're on minus 3. So minus 4x to the power of minus 3. The minus 4 comes down and multiplies. Now we're already minus here, so when the minus comes down and multiplies, we're going to go plus. So plus 12, x, drop the power by 1, x to the power of minus 5. And like last time, the plus 5 on the end just disappears when you differentiate. And there you go, there's your final answer. Okay, so as long as you're confident going from fractions to powers by putting a minus in on your power, okay, and sometimes you have to include a coefficient as well if it's not 1 over. So we have had a 2 over and a 3 over in this question, and they just became our coefficients. So as long as you can convert to index form, you can follow your normal standard rules for differentiation, which is bring your power down and multiply and drop the power by 1.